Is there anyone in here who has not turned in their chapter 2 test that hasn't spoken to me about it? Okay. I just have a couple of outliers, and I should have everything fixed up so that we can go over the test on Thursday. By and large, the average was great. Okay. So I'm continuing on with chapter 3, and the last thing we did was 3.5, which was identifying statements. If a statement was always true, we said it was tautology. If it was always false, we said it was self-contradictory. And if it was sometimes true and sometimes false, we said it was contingent. Okay? And so what we're going to do today in 3.6 is we're going to compare statements, all right, and categorize them. And then we'll do one more topic, which is calculating validity by means of a truth table. And then we're done with respect to the content of the chapter. Has everybody got that? And that will be perfect because a quiz opens up on Thursday to be done by Sunday. We'll go over the quiz on Tuesday. And so we have Thursday and all of next week to make sure we've got chapter 3 under control. Chapter 3 is very mechanical, and so if you get it, I mean, everybody should be getting an A on chapter 3. Okay? All right. Let's remind ourselves of the most basic part of chapter 3, and that is the basic truth table. Okay? So we want to know when a conjunction is true and when it's false. And so we're going to consider all the possible combinations of truth values of its parts. That's this. And so this is interpretation 1, where both are true. And we said when a conjunction, when both parts of it are true, is what? True. And if one or more parts of it are false, the whole conjunction is false. Okay? And then we also said, well, when is it the case that a disjunction is true or false? Remember, this is inclusive or, one or the other or both. When they're both true, the disjunction is true. When the first one is true but the second is false, it's true. Vice versa is true. The only time a disjunction is false is when both disjuncts are false. Okay? And then we have the conditional, and we said there's only one time the conditional is false, and that's when the antecedent is true and the consequent is false. That's when it's false. Otherwise, it's true. We also have the biconditional, box if only a circle. And I said the easy way to remember this is think of that triple bar as a sameness sign. If the truth values of the parts are the same, it's true. So here they're the same. True, true is true. True, false is false. False, true is false. Here they're the same. They're both false, so that makes the biconditional true. And then there's one other thing, the negation. If the box is true, then not box would be false. And if box is false, not box would be true. And those are all the truth functions for all the logical operators that we have. This is the basis of 90% of the chapter, being able to apply this. Okay. So, and remember last time we did different kinds of statements. Statement was always true, was a tautology, always false, self-contradictory, and if it was sometimes true and sometimes false, it was said to be contingent. Okay, now we're going to compare statements, and there's logically equivalent. Let me write them over here. okay? Two statements are logically equivalent if they have matching truth values for every possible interpretation. So that means for each line, they end up having the same truth value, okay? And then there's logically contradictory. Okay, two statements are logically contradictory if they have opposite truth values for every possible interpretation. So two statements are logically contradictory if they have opposite truth values for every possible interpretation. Okay, and all of this is in the book, okay? And the wording in the book might be slightly different. It might be much more precise, okay? And then there's two other terms that we need to talk about, and that is consistent and inconsistent. So, two statements are consistent if there is at least one interpretation in which, or it should be for which both are true. One interpretation in which both statements are true. And inconsistent. Two statements are inconsistent if there is no interpretation. There is no interpretation in which both statements are true. All right, so that's all kind of meaningless until we actually start working some problems. So let's do some. Okay, I'm working problems from 3.6, the homework 3.6, and I will do homework problem number 1 first, and we have G and K, and we have not G or K, and we could also have not K and not G, I think. Yes, okay. So basically what we're gonna do is we're gonna run a truth table for both of these simultaneously. And so look, we have the statement const G and K, and since there's 2 of them, that means we have 4 possible interpretations. And so let's come up with all the combinations of truth values. True, false, true, false, true, true, false, false. Okay, that's all the combination of truth values. So now what we're going to do is we're going to figure out the truth value of this and the truth value of that for each of these different interpretations. Okay, so we're going to deal with interpretation 1 first, where both are true. Okay, and so G is true here and K is true. So if we did the or, true is what? Say true. True. But then we have to not it, and so our final answer is false. And I'm going to do this. This stands for, that's my final answer. That's the main logical operator. Okay, so it's false right there. Let's go over here and calculate this. Now, look, don't do stuff like, well, I'll put the opposite value in because there's a negation outside here and stuff like that. No, just work from inside the brackets out. So first I have to figure out not K. Not K would be the opposite of this column. So instead of true, false, I'm going to write false, true, and then I have to and it with the not G, and G goes true, true, false, false. So not G would be false, false, true, true. So now I'm going to and those two things together. Okay? False and false is false. True and false is false. False and true is false. And true is true. So I'm going to cross those out because this is the result. But now I have to negate it. I don't know why I just only did one of these over here. So negated, I get true, 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 and false. So there's my final value for this one. Okay, over here, I've only done the first one. Okay, let's look at this. G or K. True or false is true, but negated makes it false. False or true is true, negated makes it false. False or false is false.